This video is part of a series. Complete the previous videos in this playlist before you start this video. The complete playlist information, the material and the code file information is given in the video description below.
Today we are going to discuss data visualizations using Python packages. There are several data visualization tools that are dedicated for only visualization, something like Tableau, ClickView, Spotfire and all that. There are some Python packages as well we can use for visualizations. Okay, so how do you draw box plots, Violin plots, histograms? There are different type of plots that will give us the relationships between the variables. We are going to see data visualization techniques today using Python packages. Okay. One important point that you need to know before you even start data visualization is visualization is not about creating simply beautiful charts. No. A lot of people have this misconception. A beautiful visualization, a good visualization, they think that a visualization that appears very neat or very glamorous to the eyes, that is not about visualization. It's about representing your data using the appropriate charts. Basically, if you're drawing a visualization, if you're drawing a chart, whatever you want to tell in these bullet points, whatever this graph has to tell in these bullet points, without reading these bullet points, I should be able to understand just by looking at the chart. I should be able to understand what you're trying to highlight. Let's say this is a country-wise, some kind of average income chart or country-wise average expenses chart. If you want to highlight a particular country, when I look at that visualization, when I look at the chart, automatically my eyes should go onto that country without me reading whatever is your bullet points. I should be able to get that. That is visualization. Okay. Let us see what are some of the visualization packages and techniques that we can use in Python. We will start one by one. Remember, depending on the type of the variable, our visualization changes. We cannot apply the same type of chart for everything. We will start with continuous variables. What is a continuous variable? Do you know? Tell me in the chat window in your own words. What is a continuous variable? Or give me an example of continuous variable. A continuous variable. Give me an example in the chat window. A continuous variable takes any value within a certain range. Within a certain range, it can take any value. That is a continuous variable. Temperature, yes, temperature is a continuous variable. Can temperature be 20 degrees? Yes. Can temperature be 30 degrees? Yes. Can temperature be 25 degrees? Yes. Can temperature be 25.5 degrees? Yes. Can temperature will be 25.51 degrees? Yes. Continuous variable takes any value within a given range. The opposite to this is discrete variable. What do you mean by discrete variable? A discrete variable, it takes only discrete values. It doesn't take continuous values. It takes discrete values. So continuous variable examples are temperature, balance, bank balance, income. These are all continuous variables. Okay. What is a discrete variable? Price is a continuous variable. That's right. What is a discrete variable? A discrete variable only takes discrete values. Within a range, they cannot take all the values in between. An example is, tell me one example of discrete variable, anybody? Think about this. Number of loans that you have. Number of loans can be either 0 or 1 or 2 or 3 or 4. Can the number of loans be 1.5? No. Can the number of loans be 2.8? No. They can be either 0 or 1 or 2. That's it. They can never be in between. Number of loans, number of dependents. These are all number of house loans, number of auto loans, basically count kind of variables. These are all discrete variables where you cannot have values in between. Within a range, they take discrete values. Yeah, anything related to count and all that. So there is a different way to handle the discrete variables. There is a different way to handle the continuous variables. Within discrete variable, there is another type called categorical. Categorical variables. Now this number of loans and all that, they are ordinal. You can order them. You can put them in an order. You can put them like there is one lesser number, higher number. Categorical is a slightly different one. Categorical variables also discrete, but they are slightly different. You cannot actually order them. They are non-ordinal, which means there will be some categories, but you cannot tell which one is higher, which one is lower, right? Gender. That's the right example. Gender is a good example of categorical variable. Any other categorical variable? Yes, no values, Boolean values, yes or no. House loan, I mean, if we convert this, loan, house loan, yes or no. House loan indicator, yes or no.
marital status.
Marital status, married or not married, those are categorical variables. Country name, if you have limited number of countries, that is also categorical variable. That's right. I think you have a basic idea on the type of variables now. As and when we go further, you will get to know more about these variables. First, we will start with continuous variables. So continuous variables, there are 2-3 different ways of showing the continuous variable. One of this method we already discussed. Maybe just think about it. There is a way we represent the continuous variable that will also give us the distribution of the variable, and we will get to know what are the ranges of the variable from minimum value till the maximum value. We get to see everything. If there are any outliers also, we get to know that. Do you remember that plot that we have drawn for continuous variables that will give us whether there are any outliers or not? Yes, for continuous variable distributions, you can directly draw the box plot. There's a variable called balance. If you want to show the whole information about balance, the best plot that you can show is you can, from the minimum till the maximum, you can draw the box plot. What does box plot tell us? Can somebody tell me what do you infer from the box plot, or what does this particular box plot tell us about this balance variable? What does this particular box plot tell us? What do you get the information? Always make a comment on the outliers. Whenever you draw the box plot, remember, you draw the box plot as a data scientist, you're going to make 1 or 2 comments on this graph, right? You're going to comment, looks like the box is really compressed here, which contains almost till here 75% of the data. That means there are some outliers in the data. Maybe you can also talk about the minimum value and the maximum value range, like maximum, it is going almost till 100,000. Minimum is going even below 0, etc., etc. Negative balances are also there. But the important point that you are going to make is outlier. Yes. What about this one? Let us suppose you are creating a box plot for age variable. Again, you are going to say, what is the minimum value? Maybe around 20. What is the maximum value? Maybe beyond 90. There are slightly outliers here. There is a beautiful way of putting it. Box plot looks boring. There is a beautiful way of drawing the same one, which is known as violin plot. So basically here, instead of box, this violin will be shown. So this is the violin plot for our variable called balance. This particular box plot, this is the original box plot. Violin plot is a kind of variation of the box plot only. It also tries to show the same thing. And this is the violin plot for the age variable. You talk about the outliers only. Okay. Here also you talk about you say that there are some values that are beyond this. If this violin plot is confusing, better to stick to our regular box plot, because here we get the minimum value, percentile values, median value, 75 percentile, and the maximum value. We'll also get some idea on the box plot. Okay. Maybe you can draw both the ones also, not at all a problem. You can show box plot as well as side by side you can show the violin plot. Okay. These are the methods to show the continuous variable distribution. There is one more thing that you can do. Continuous variables can also be shown by drawing the histograms. Histograms are something like distribution. Here we are largely focusing on the minimum percentile, which is a 0 percentile value, 25 percentile value. We are actually taking some important points from the distribution of the variable, 50 percentile, 75 percentile, and the 100 percentile value, and showing them in a graph. Whereas if you want to really show the complete distribution, that means from minimum to maximum, I don't want to simply focus on this, I want to show everything, then you can draw something called histograms. That means from minimum value till the maximum value. This is a histogram for age variable. You will roughly get the same one, like whatever is the values that you are seeing here. Near the 50 percentile you have 40, near the 25 percentile you have 30, and a minimum value 20. The same thing you will get, but you will see the original distribution. In fact, you can also add a continuous distribution kind of thing also by adding one more option, which is present in this one. We will see what is the option here. If we say KD equal to false, then that particular continuous smoothing curve will go away. Otherwise, by default, the smoothing curve will also show. Remember, this is not a different one. It is same histogram. They are trying to show this cumulative distribution or the count or the smoothing curve for the same frequency graph. At the end of the day, out of all these graphs, we are trying to convey. What message are you trying to convey? Take a note of these 2 points. When you are giving any visualization about a continuous variable, always talk about the range. What do you mean by range? What is the minimum value? What is the maximum value? That is the first one that you want to make a comment. You also want to make a comment whether there are any presence of outliers. Though maximum value is around 100, I think 60 is the point, or 62 is the point where it starts saturating. Very few points are above 60. Most of the points are in this range, like that. From here and the previous two plots, all of them are trying to tell us the same thing. This is the area that we have to focus. 75% of the data is below this. Maybe a lot of data is below this. So make a comment on the outliers, make a comment on the range. What I'm saying is, when you are doing this, when I'm driving it, it looks like everything is falling fine. First, we will do this exercise. Next, I will give you a challenge. Okay. I will ask you one or two questions. You may have to create these graphs and tell me the answer by looking at these graphs. Okay. First, let us open the code file and try to draw these continuous variables visualizations. Okay. All of you open the code file. So first, get this data set. This is bank telemarketing data. This data set has been hosted on GitHub. You can directly download it from GitHub itself. This is the bank marketing data. Here is the head of the data. Here looks like there is only one column. The problem here is with the delimiter is not comma, it is semicolon. That's why everything is right into one column. So while reading it carefully, we have to correct it. Separator is not comma, though it's a CSV file, comma separator, but there is a special separator here. Separator is semicolon. When I correct it as semicolon, then you will get to see the original number of columns, which is 17. Now, when you see the head of the data, you will see all the columns properly laid out, and this is the information. Okay. Some variables are numerical, some variables are non-numerical, some variables are categorical. We'll try to go through all the variables, okay, one by one. As of now, let us focus on continuous variables. Balance is one of the variable, which is bank balance. So let us draw a box plot for the balance, which we have seen. There are outliers. Box plot for age variable. This is the one. In fact, these suggested outliers that you see, if you want to get rid of those suggested outliers, you can actually push that range. So internally, they are using some kind of range, whisker range or something. We can modify that range and remove it, but you can ignore that as well. Always consider the maximum value as the actual box plot. Violin plots are exactly like box plots, a different way of representation, trying to show the distribution, like around 50, how many points are there, around the width they are trying to show rather than a simple box. But
in the violin, how will to find out the maximum and the minimum?
Maximum minimum is easy. Outliers will be difficult. Maximum is the max point, this one.
Okay.
So around this one and this one. But the difficult point would be like the way we have outliers here. Okay. 75, 25 and all that, like the way we have in box plot. Those will be difficult in violin. Maybe along with violin, we may have to put describe also. Then looking at the describe values where you will get percentiles, and violin would might make sense. Yeah. Some places where there are sure short outliers like this balance one, violin also shows like this. Otherwise it might not be that easy. So just a box plot different version, but in terms of clarity, box plot is much more clear.
In the age violin,
yeah,
how will explain this chart?
So this chart is explained like this. So we have to say the maximum number of data points are around this one, wherever you see the largest width. The maximum number of data points, maybe let us suppose this is 35 or 36, let us suppose that is 35. So you will say maximum number of points are around 35. There are some points around 40. There are some points like slowly by 60, most of the population is done. Okay.
Yes.
Beyond 60 also there are some people, but very less number of people are there. So this width tells you the count of people taking that particular value. If you come to this one, 20, there are only very few people. As it increases, slowly it goes up, then you will get 30, 40 and all that. Okay.
So here also outlier is there, right?
Yeah, for sure. So if we are seeing outliers in box plot, since this data is same data, you will make a conclusion that there are outliers here as well.
Okay.
Yeah. So this width is the one that will tell us the count of people which are falling in that particular range. Maybe one comment we can make is the width is really high around this range. Maybe we will say maybe 30 to 40 is the range where a lot of customers or the lot of data points are lying around. Clear? Or maybe your violin plot along with the histogram might complete the whole story. If you see the histogram of age, as we discussed, 30 to 40 is the people where there are a lot of count, isn't it? Which is also visible in the violin plot. So this along with histogram might give you the complete information, 30 to 40 range, or where exactly is this? Yeah, this is the one, 30 to 40, where a lot of counts are there. And how do you create a histogram? You take the overall range from minimum value to maximum value, cut it into 10 bins, and count how many customers or how many items are there in each of the bin, in each of the bucket, how many items are there. So basically, there are some values that are starting from 18. Simply, they might have cut it into 10 bins. So 0 to 20, very few numbers are there. 20 to 30, somewhat. 30 to 40, maximum number of range. You can see that, right? 30 to 40. 40 to 50, somewhat lesser. 50 to 60, lesser. 60 to 70, 70 to 80, 90, very less. The same thing is re-represented in this one. The same thing is again represented using percentiles and all that in this one. So all these three methods are for the same type of variable, which are continuous variables. Any questions on this? Will you be able to look at this graph and make a comment that what is the maximum value, what is the minimum value? Are there any outliers present in the data? Will you be able to look at these graphs?
20 to 30 to 40, there is a maximum.
Maximum frequency is there from 30 to 40,
yes.
and then beyond 60, very few number of
Very
people
few
are
number.
there. Correct, yes. Yeah. But at the end of the day, you think from the reader point of view or the person who is looking at these graphs, the point that you want to convey, is it coming out of this graph or not? That we need to answer. If the point is not coming out, maybe we have to give more backup with some more data or more graphs, or we may have to add a table just beside it, or we may have to add maybe 1 or 2 lines we have to overlay just to make sure that the point that we are conveying is going out or appearing in this chart.
But how will you get to know the outliers in the histogram?
We have to look at the, like, if you want to know 100%, then you have to look at the box plot. Okay. Otherwise, here you will get a slight hint where the whole data will be in a certain range, and there will be some points that are very far away from the rest of the range. But decisive way, if you want to take it, you have to take it from the box plot.
Said that below one, 14.
Yeah. Yes.
So what does it mean, sir? It is
Try to give it a first shot. I'll explain you this. There are 2-3 comments that you have to make. The first comment is, what are the minimum values? What are the maximum values? That is the first comment.
yes.
So you will be making a comment on the minimum value, maximum value. Can somebody make the next comment? Are there any outliers in this data?
Yes, sir.
It's a very easy one, isn't it? We can very easily say there are outliers, because looks like most of the data is concentrated somewhere here, not even shown in the graph. But let me guess that as 5,000 or something. Most of the data is below 5,000, but there are some data points that are going till almost 100,000. So I think there is a sure short case of outliers, isn't it?
Yes, sir.
Can you make that comment looking at this one? So basically, this is that graph where you see that you will make a comment saying that most of the data is below this number. Maybe looking at the percentiles and all that, we will get to know maybe this is something like 5,000. 90% of the data is less than 5,000. Less than 10% of the data is going beyond 5,000. It is going as much as 100,000. Definitely, this will contribute to outliers. Outliers are present, definitely present in this one. Maybe the previous one, I understand maybe it is not that easy here because the age variable is not showing that very reliant outliers, because age doesn't have that much far away outliers. Even if we look at the box plot, we can see that balance variable, sure short outliers are there. Age is still not very far away, or very extreme outliers are not present. That's why histogram also not showing a very decisive conclusive evidence. Whereas when it comes to your balance variable, this variable, definitely there are some outliers in this variable. Clear? Okay, let me give you some more examples. Now tell me, what about this one? Does it have any outliers? There is one variable. This variable name is previous. Okay, this previous takes from somewhere around 0 to 250. All of you need to tell me, previous, does it have outliers? Perfect. All of you are saying yes, yes. What about this one? P days. P days, minimum value is 0, maximum value is 800. P days, does it have outliers? Now this is age variable. Compared to this, does it have extreme outliers, or it does have outliers but not as extreme as this one?
Not extreme outliers.
Not extreme outliers, but it does have some portion of outliers, isn't it? Not extreme, not very extreme. That's right. Okay. So let us do these first. Then I'll give you one more example. There, I'll give you one more chance whether you can do it on your own or not. These are some of the examples that I have shown. What you can do is, if you want to automate this quickly, if you want to do it on, on every variable, what you can do is you will write this particular code where you get all the d types in integer or float. Basically, you will get all the numerical columns and then draw the histogram for them. This is known as list comprehension. You know how it works? You want to get all the numerical columns. Call for column in bank columns if it is in these two types. Let me explain how list comprehension works. This we may use multiple times. So in a list comprehension, you write result here, result, condition 1, space, condition 2, space, condition 3. You keep on writing the conditions. So here my result is I want to get the column name. Okay. What is the condition 1? For all columns, for column in the column names, that means df dot columns or anything, that is condition number 1 for me. So for every column I want to get the column name, but this will give me every column name. What is my condition number 2? Tell me. I want to get only numerical columns. That means space, I have to put the condition number 2 if column is in numerical format. So that is how I'm writing. Let me explain that once again. Result is the column name for column in columns. All of you, have you understood this first condition? Quickly confirm that to me. For column in bank data columns. This, what will this fetch me? If I write only this much of the code, can you guess what will be the result if I write only this much of the code? All the columns will be printed. Perfect. What is my second condition? If the column d type is either numeric or float. Okay. If this is the second condition, if the column type is either this or this, then I want it to be printed. Apparently, the numerical columns are age, balance, day, duration, campaign, P days, previous. For all of them, I want to draw the chart. So this will be the numerical columns. If you print the numerical columns, you will get this result. Now, here is the for loop that will run on all the columns. Look at this plot figure, that is a usual one. For column in numerical columns, that means column 1, column 2, like age, balance, and all that. SNS is the package. Seaborn, the package name is Seaborn. This is a dedicated visualization package. Matplotlib is also a good package. Seaborn is also a good package. But I found a lot of people are using Seaborn. It has slightly advanced, very cool visualizations are there. So Matplotlib along with Seaborn is what I suggest to you. So Seaborn, dist plot, basically for histogram drawing. Histogram is also known as distribution. Yeah. And then you take the column, whichever column you want to draw the histogram. And this is the title, column name histogram, and then plot dot show. So this will go through all the columns one by one, give you the result. All of you execute till here. Then I'll introduce a new data set to you. Then I'll ask you questions that are related to this numerical column. Then we'll proceed further. Okay, go ahead. Now let us try this, whether our understanding, whether we have understood everything correctly or not on an actual data set. This data set is Roseman store sales data. This is like a supermarket in US or some other country. What they do is, they're just like any supermarket, they send different type of products. So they have several stores. So this was a competition that was run on Kaggle 5 years ago. And look at the prize money. For anybody who solves this problem. Right now, we are not trying to solve the problem. We are trying to solve one part of the problem, which is before solving the problem, you want to get a good understanding of data visualization. You want to explore the data. Let us do the exploratory data analysis part of it. Okay. So the columns are quite common. You have store ID, store sales in a particular day, number of customers that have appeared in that particular day, what is the sales, the turnover on any given day, whether the store was open or not on a given day, whether it was a state holiday or not, whether it is a school holiday or not, what is the store type. There are different store types, A, B, C, D. Maybe like in more and all that, you have more mega store than more small store. Like that, there are different store types. Okay. Assortment type, basic, extra, extended, different. Competitor distance. Competitor distance means you are Roseman, this particular company is Roseman. Maybe what about some other Walmart or Target, which is a competition who is nearby. Competition open since which month, promotion is running or not, promotion 2 is running or not, promotion interval is how much. This is the data that we have. Okay. What we want to do is we want to create some visualization so that we can get some idea on this data. Okay. Let us go back and see what is the problem statement. So right now, my problem statement, my challenge to you is import this data set. Okay. Now there is a variable called sales, daily sales, right? What you need to tell me is there, so basically what is the minimum sales, maximum sales, and are there any outliers in sales? Outliers means, are there any days that are having extremely high sales? That is my first question. And you should tell the answer without using any specific notes or anything. Just by showing me the graph, you should be able to tell the answer. So the first question is, are there any outliers in the sales? How is it working? And the second question is, are there any outliers in the customers, in the sense, are there any days where customers are extremely high compared to the usual days? Are there any days where customers are extremely high? So basically two simple questions. My guess, usual guess, what I'm thinking is, since this is regular real data, I'm thinking that definitely there will be some outliers. Definitely there will be some days like festive seasons or Thanksgiving Day or something where you will have high sales, maybe high customers also present. But you have to prove that from the data. So go back to your code here, go back to your code, first import this data and get the plots, all the plots in one shot, Violin plot, box plot, distribution plot, everything in one shot for sales, for customers. I'm not going to execute it. You will execute and tell me whether there are any outliers. So write in the chat window, minimum value, maximum value of the sales, first comment, second comment, outliers present or not. Okay, go ahead. All of you. This data set has more than 1,000,000 rows. Okay, nearly how many rows are there? Nearly 1.01 million rows are there. And when you look at the sales data, you can make a comment. Minimum sales obviously 0. Maximum sale in a day, it has gone up to almost 40,000 within a single store itself. And there are some outliers. Usually median, if you see around 5,000 or something. Maybe when we see the describe, we will get to know. Looks like the usual range. The usual range is somewhere 15,000 or somewhere it is stopping, but it is going as much as 40,000, isn't it? Outliers are present. Same information is given by Violin plot. In the Violin plot, the maximum distribution is here and it is going thinner and thinner here. Yeah, same information is given by histogram. These zeros are high. Can you tell me why zeros are high? When the store is closed, definitely you will have no sales. Definitely those counts will be definitely there. That is where one peak is there, 0. And most of the values are in this range, 6,000 or 5,000 and all that. After this 15 or 16,000, it started dampening. I think 15, 16,000 is the critical value, most slightly maximum value. Beyond that, they are all outliers. So I can very confidently say there are outliers in the sales. For the daily sales, there are outliers. Similar story you can tell about the customers. What is the absolute maximum value, and then the range that you can give it to the user, saying that though absolute maximum is around 7,000, but realistic maximum is around 1,500 or something. All of you are following me, right? Around realistic maximum looking around 1,600 or 2,000 or maximum 2,000. Beyond that, there are outliers present in this one as well. That is how you use these plots for talking about continuous variables. Are you confident? Can you take any data set in future? Can you convey this message to the reader that there are outliers present or not? Where is the maximum distribution of the data and whether the outlier is present or not? That's much only. I mean, I'm not expecting a lot of strategies from here and all that. A simple visualization with these 2 points. Are you confident? Perfect. The next type of variables is categorical variables. The approach that you have followed for visualizing numerical variables is very different. And for categorical variables, we cannot draw the histograms, we cannot draw the box plots, because by nature, categorical variables are such that you cannot order them. You cannot say this is the minimum value, this is the maximum value. There is no such thing. We have discussed some of the categorical variable examples. Give me another example of categorical variable. Region. What are the categories in it? East, west, north, south. Gender, male, female. Give me another categorical variable. Give me another categorical variable.
Product category.
Product category, right? Very good. Store category, like this in these examples. These are all
Grade.
categorical variables. Grade, A, B, C, D. Yeah. So these categorical variables visualization. The most famous one is the bar chart. Category A, category B, category C, category D, and the bar chart of all these variables. But here you see that these category names are distorted. Maybe you can adjust them in an angle, or instead of vertical bar chart, let this be horizontal bar chart. then you will get to see these names very well managed. Then what is the point that you have to make after creating this bar chart? You have to talk about the most frequent and the least frequent categories. If you're not talking about the least frequent categories, it's perfectly fine. But top 2 or top 3 categories here that are most frequent, you have to make a comment. Depending on the business that you are handling, are they as per the expectation? Or if there is something which is surprising, you are not expecting the management count to be really high, but if it is high, make sure it is highlighted. If you are expecting services count to be high, but it is lower than the rest of the ones, then you may have to highlight that. Always talk about the top 5 or top 3 categories in this bar chart. Are you with me? So this is a very simple one. Bar chart. For every category, you will create a bar. And what is the length of the bar? I think all of you know that, right? What is the length of the bar? Length of the bar is number of times it has appeared. So let us suppose there are 100 records. Out of them, 20 times management has come, 30 times technician has come, entrepreneur has come, like let's say 35 times. Then entrepreneur will have a larger bar, and then slightly smaller bar will be for this one, and this will be the slightly smaller bar. Yeah. Can we sort the bars? Yes, we can sort the bars, and this will look like this one. Sorting the bars also possible. Yeah. Maybe here in SNS count plot, we have to check whether that option is there or not, or we may have to add that or first count it and send this data. But I think it must be possible. Yeah? I have seen some places where sorting is done. Same way, what we will do, we will take all the categorical variables, result for all the columns. If the columns is object, again, we have to be careful here. Sometimes some categories are too many. If you have specifically categorical variables present, you can write them down. But here it's an easy option for me. If the category, if the variable is object type, I'm keeping them in categorical variables, drawing the box plots, okay, for all the categorical variables. This is an easy one. Again, we will go back to the Roseman sales data, and then I'll give you some questions on it. First, let us finish this one. Quickly create these bar charts. We will take the question. Then I'll give you the connected question on the new sales data. Okay, go ahead, all of you. Complete this. Send me a notification in the chat window. So this is a usual bar plot. This is the vertical bar. These are the horizontal bar chart. For all the categories, we will get the bar. One of the question was, can we sort these bars? I think that's a good homework question. Note it down. Explore on how to sort this in such a way that the lengthiest bar will be appearing either at the top or the bottom. And then within SNS, is there any option? Maybe when you go to this SNS count plot, here, if you find any option in any of this sorting, then you should be able to find that one. Okay. Now, coming back to Roseman store sales data, I want to know which store type has the maximum count. Is it store type A, B, C, D? I don't know what are the store types, but there is a column called the store type. But where is the maximum count? Which store type has the maximum count? And there is another categorical variable called assortment type. Which one has the maximum count? These are fairly simple questions. I don't think there's a lot of knowledge required to answer this. Quickly create the box plot. Try to answer the questions in the chat window, all of you. This is a store type. And then this is the assortment type. As you can see, it's a fairly easy answer. Store type A and assortment type A is the maximum.
Continue with the next video in the playlist. We are covering everything step by step. If you have any questions or the comments, please post them in the comments window below.